Good morning. Today we're going over conversions and dimensional analysis for our homework. And to start, we've got a couple of conversions that have formulas. So we're going to use this formula or these two formulas. And just to let you know, for these formulas, I would give these to you on a test. You don't have to memorize these. And you guys know how to solve formulas because you've taken algebra before. We're just going to plug and chug. If I have 37 degrees Celsius and I want Fahrenheit, then I find the formula to go between Celsius and Fahrenheit and I plug it in. So if we plug it in there, we would find temperature in Celsius is 37 degrees. That equals the temperature in Fahrenheit minus 32 divided by 1.8 to solve for the temperature in Fahrenheit. We're going to multiply both sides by 1.8. So those cancel. And then I'm going to add 32 to both sides. So then minus 32 plus 32 cancels, and what I get is 1.8 times 37 plus 32 equals my temperature in Fahrenheit. And I can plug that into my handy-dandy calculator. Gives me a temperature of 98.6. For this next problem, we are told that Becky is going to take her dog for a walk in the park, and she sees that it's 82 Fahrenheit outside. They want to know, what is this in Kelvin? The key here is that we have to convert first from Fahrenheit to Celsius so that we can use the second formula to convert from Celsius to Kelvin. So in the first place, we see the temperature in Celsius is the temperature in Fahrenheit. They gave 82 minus 32 divided by 1.8. And that is, when we plug it in, 27.77. Then the temperature in Kelvin is the temperature in Celsius plus 273.15. So I'm going to insert this right here. 27.77 plus 273.15 gives me 300.9 or 300 Kelvin. Now they want us to arrange these in order of decreasing temperature, and it's going to help if we can convert these all to the same thing. So let's convert them all to Celsius, because we've got something that'll get us from Kelvin to Celsius, and we have a formula that'll take us from Fahrenheit to Celsius. So let's do that. So starting with the first one, 133F. We're going to say 133F minus 32 divided by 1.8 gives us a temperature of 56 degrees Celsius. So 133F equals 56 Celsius. For the next one, we have got 273K, and I'm going to subtract 273.15, so that's going to be about 0 Celsius. So 273K equals 0 Celsius. 95 Fahrenheit, 95 minus 32 divided by 1.8 gives me 35 Celsius. Next we have 25 Celsius, so we don't have to convert that. 351K minus 273.15 gives me 78 Celsius. 58 Fahrenheit, 58 minus 32 divided by 1.8 gives me 14 Celsius. And last of all, we have got 146 Celsius. Okay, so 146 is the highest. And then we've got 25, we'll put those on the timeline. Then we said 56 Celsius. It's going to be next highest, followed by 35. That was the 95 Fahrenheit. Oh, no, 78 Celsius is going to be higher than 56. That was this one. 58 Fahrenheit was 14 Celsius, so that's going to go down here. And 273 was 0. So here we're going to do the same thing that we just did, except now we're going to do it from the human body temperature. If it's 98.6 Fahrenheit, what is that in Celsius? Well, here's our equation. 98.6 minus 32 divided by 1.8 gives us 37 Celsius. And then what is that in Kelvin? Well, if I already have the Celsius, I remember that the temperature in Kelvin is equal to the temperature in Celsius plus 273.15. So that's going to be 310. All right, temperature sensitive bath toy Color changes from 40 to 49. So what would that be for Fahrenheit? 40 Celsius. We'd multiply that by 1.8 and then add 32. 104. And then if I start with 49, multiply that by 1.8, add 32, 120. Again, I'll give you these formulas. You do not have to memorize them. All right, next we're looking at conversion factors. So this is doing math with dimensional analysis. And they give some examples here where you use these conversion factors, which allow you to cancel out these dimensions or units so that you're left with the units that you want. And so for part A here, it's just saying what conversion factor would I use if I wanted to convert 500 grams to milligrams? Well, if I start with 500 grams and I want to go to milligrams, I need a conversion factor that puts milligrams on top and grams on the bottom so that the grams will cancel and I'll be left with milligrams. So I need milligrams on top and grams on the bottom. And that is this one. Next, if I have milligrams and I want grams, 7 milligrams, then in this case I want something with milligrams on top, on the bottom, so those will cancel, and grams on the top because that's what they want. So grams on the top, milligrams on the bottom. That's right here. Grams to kilograms. If I have 60 grams, I want a conversion factor with grams on the bottom and kilograms on the top. So my grams will cancel and I'll be left with kilograms. So kilograms on the top, grams on the bottom. That's this one. And next, if I have milligrams and they want micrograms, 0.02, then I need something with milligrams on the bottom and micrograms on the top so that I can cancel my milligrams. So that's this one, micrograms on top. Now, which one of these is the right way to go about it? If you need 0.100 grams of drug, you have tablets that contain 50 mg of drug. So they're doing a conversion. You're going to go from grams to milligrams and then milligrams to tablets. So you'll use the conversion factor of 1 gram is 1,000 milligrams, and then the conversion factor of 1 tablet is 50 milligrams. Your milligrams should cancel, your grams should cancel. You want to be left with tablets. So this is the great thing about dimensional analysis. It'll tell you if you are doing it right or if you're doing it wrong. So for instance, in this case, grams times grams will give you grams squared. You need to eliminate the grams, so you have to divide by grams. So this is better, grams divided by grams, those should cancel, good. That leaves milligrams on top, milligrams divided by milligrams, those should cancel, great. And that leaves tablet on top, so that looks like it'll work. Just checking these ones, grams divided by grams, great. Milligrams, no, when I multiply here, I'm going to get milligrams squared. And tablets will be on the bottom. It doesn't give me the units that I want at all. I need to be left with just tablets and tablets on top. Again, this will give you grams squared. You're not canceling out grams, so this is the right answer. All right, so next, if the patient has to be administered a dosage of 2 tablets every 8 hours for 7 days, how many tablets do you need? All right, so we need 2 tablets every 8 hours, and we want 7 days. See, I've set this up so days cancel, hours cancels, and I'm left with the number of tablets I need. So they told us you're going to need 2 tablets every 8 hours, and since we knew it was 7 days, you had to add in this conversion factor. They didn't give it to you. You had to see, hey, you know what? I'm going to need to know the number of hours in a day in order to get to the point where I can start to eliminate some of that. Now you could also go backwards. You could say, I need to know number of tablets, so I'm going to start here, 2 tablets, 8 hours, and then knowing I have to get rid of hours, 24 hours in 1 day. And then you're going to be on a 7-day course. So these cancel, these cancel. The answer is the same either direction. Either way is appropriate. Should get you the same answer. 7 times 24 times 2 divided by 8 gives me 42 tablets. Next, what volume of sulfuric acid is needed to obtain 128 grams? There's a formula for density, but please don't go look it up. You see, they want milliliters, they give you grams, and they give you a conversion factor that goes between grams and milliliters. Easy peasy. 128 grams 1.83 grams in, there's no number here, so that means 1. I want grams to cancel, so I'm going to actually put that on the bottom. Done. Grams cancel. I have my answer in milliliters, which is what they asked for. I would so much rather you use dimensional analysis than memorize a formula. I will ask you density questions on the exam. I will not give you a formula. So just heads up there. Next, same story. If I ask for the density and I give grams and I give milliliters, you don't even have to know the formula. You can just look at my answers and see, hey, they're all given in units that have grams divided by milliliters. That must mean I should take my grams and divide them by my milliliters. 27.2 grams, 35.0 milliliters equals 0.778 grams per milliliter. Now notice here, I don't put anything here and I don't put anything there. That's okay. I only put something top and bottom if I'm using an actual conversion factor. Otherwise, if I'm using just data that was given, I can plug that into the top or the bottom bracket at will without concern. Okay. Here I'm using a conversion factor that was given. Here I'm just putting the units where I want the units to be. That's how dimensional analysis works. All right, how many liters of fat would have to be removed to result in a 6.5 pound weight loss? And first, they didn't tell you the conversion between pounds and other units of mass, but you can see if we have 6.5 pounds and we want to lose that much, we've got 0.94 grams per milliliter of fat, and they want to know liters. We've got some unit conversions we're going to need to do. Milliliters will have to be converted to liters, and pounds will have to be converted probably first to kilograms and from there to grams. And that will help us get rid of that. So I can either start with the 6.5 pounds or I can start with the milliliters on top. Doesn't really matter. I'll start with the 6.5 pounds. Conversion factor between pounds and kilograms. I'd probably give you something like this on the test, because I don't make you memorize any conversion factors that have a English unit in them, but we've got 2.2 pounds in every 1 kilogram. Then I need to get to grams. So 1 kilogram is 1,000 grams. Pounds have canceled, kilograms cancel. And now I'm going to put the grams on the bottom, 0.94 grams in 1 milliliter. That way my grams cancel. I can flip this upside down or right side up at will. I can put those units wherever I want them, wherever I need them. And next, from milliliters to liters, 1 milliliter is 1 times 10 to the negative 3 liters. All right, so milliliters cancels, and I'm left with units of liters. And now I can just plug this in. 6.5 pounds divided by 2.2 pounds in a kilogram. Multiply that by 1,000 grams in a kilogram. Divided by 0.94 grams in a milliliter. Multiplied by 1 times 10 to the negative 3. Gives me 3.14 liters. If gasoline sells for 95.4 cents per liter, what is it on a cost per gallon? Here they even gave you the conversion factor, so that's nice. 95.4 cents per liter. That's a cents. They want dollar per gallon. So we're going to have to convert from liters to gallons, but also from cents to dollars. And let's do that right now. That's easy. 100 cents is $1. We cancel that out. If we want to go from liters to gallon, they told us liters to quarts. So 1 liter, 1.06 quarts. Liters cancel, and I've got quarts. I don't want quarts, I want gallons. So conversion factor between quarts and gallons. There are 4 quarts in 1 gallon. Quarts cancel. Now I just plug it in. 360. Okay, let's do this with dosing. Patient needs to take 625 milligrams of ibuprofen twice daily. So one dose is 625 milligrams. And you need 2 doses in 1 day. That's what it says. Pills in the bottle are each 250 milligrams. So 1 tablet equals 250 milligrams. How many pills does the patient need to take? Well, okay, so they want to know pills or tablets. Let's put that front and center. 1 tablet, 250 milligrams. This is the unit we want, so we're going to keep that there and try to eliminate everything else. 250 milligrams is how big the tablet is. Where else do I have milligrams? Right here. 625 milligrams in 1 dose. Milligrams then cancels, and we get 625 divided by 250. I need to take 2.5 tablets or 2.5 pills to make that dose. Next, insulin. We've got a bottle, 275 milliliters of insulin, and we've got a concentration of 20 milligrams of insulin in every 1 milliliter. And they want to know the total mass of insulin in the bottle. So I'm going to start here because I find it really easy to start with the units that they want and then eliminate everything else away. You can do it the other direction. It works just as well, but I like it this way. 20 milligrams of insulin in 1 milliliter of solution, and I've got 275 milliliters of that solution. Milliliters cancels, and I'm left with milligrams of insulin. If I'm administering oral acetaminophen, dose of 480 milligrams from a bottle, and this is my concentration. How many milliliters do I do? 480 milligrams. And we've got 32 milligrams in 1 milliliter, so I'm going to put the 32 milligrams on the bottom. 1 milliliter on the top. That way milligrams cancels, and I'm left with the units they wanted, which is milliliters. So that's a 15 milliliter dose. Now, recommended daily dose is 1200 milligrams. If 1 cup contains 240 milligrams, how much milk if that's your only source of calcium? Okay, so I need 1200 milligrams of calcium. 1 cup is 240 milligrams, so that's just like saying 1 cup equals 240 milligrams calcium. So I'm going to put that on the bottom, 1 cup on the top. So the milligrams of calcium cancel, and that gives me my answer in cups. That's 5 cups in a day, if that's the only place you got calcium from. All right, dosage in grams per kilogram of body weight. A 115-pound woman takes 2 275 milligram tablets of penicillin. Again, dosage is grams of drug on the top and kilograms of the person on the bottom. So let's start with the penicillin. We've got 2 tablets penicillin, and 1 tablet of penicillin has 275 milligrams of penicillin. They want grams here, so 1,000 milligrams of penicillin are in 1 gram of penicillin. Now I can actually keep going. I like to stack up all my conversions on one line, but it doesn't hurt to stop and do separate conversions as well. This is okay. There's nothing wrong with doing it this way. 0.55 grams of penicillin, and now I need the kilogram of the body weight, so 115-pound woman. And remembering that there are 2.2 pounds in 1 kilogram gives us 52.3 kilogram woman. And now if I divide this by that, I get grams per kilogram, which is what they wanted. So 0.55 divided by 52.3 gives me a dose of 0.0 0.105 grams per kilogram. Now, we want a child to receive the same dosage, not the same dosage as in, let's give her 2 tablets, each having 275 milligrams. We just mean relative to her body weight, so that her body is essentially receiving the same concentration of that drug. So now that we know we have 0.0105 grams of penicillin per kilogram of body weight. We have a 30-pound child, so we're going to have to convert there. 1 kilogram is 2.2 pounds, and we have a 30-pound child. Pounds cancels, kilograms cancels. Now I'm left with the grams of penicillin. Take it back to milligrams. 1 gram of penicillin is 1,000 milligrams of penicillin. And if I'm using 125 milligram tablets instead of 275 milligram tablets, we see that 1 tablet is 125 milligrams. So your milligrams cancel and your grams cancel. So that takes us to tablets. And again, you could have done that one step at a time. You could have converted from pounds to kilograms and then plugged it in, and so on and so forth. So here we go. 0.0105 divided by 2.2 pounds in a kilogram, multiplied by 30 pounds, multiplied by 1,000 milligrams in a gram, and divided by 125 milligrams in a tablet. Looks like we're at about 1.15 tablets. Okay, now that's about 1 tablet, so she's not going to get exactly the same dose, but approximately the same dose if she takes 1 tablet. Now they want us to calculate the dosage in microgram of drug per kilogram of body weight. So if we do this, we've got a 200 milligram tablet in a 145 pound adult. Put that in per kilogram. 1 kilogram is 2.2 pounds. So your pounds cancel. I've got kilograms on the bottom, just where they want us. Now from milligrams to micrograms, I find it easier just to remember the 1 conversion, 1,000 milligrams in 1 gram. And then 1 microgram is 1 times 10 to the negative 6th grams. So I'll have to do 2 here. You don't have to do here. If you know the conversion between milli and micro, you could put that down. But for me, I just go to grams in both cases because I only have to memorize the 1 conversion factor for each of those. So here we go. 200 milligrams per 145 pounds multiplied by 2.21 pounds in a kilogram, divided by 1,000 milligrams in a gram, and then divided by 1 times 10 to the negative 6th grams in a microgram, and I get 3048, or 3.04 times 10 to the 3rd. There we are. That's it. I hope this was helpful, and hope you have a nice day.